Properties of real numbers and solving equations. Let's do it. The commutative property of addition. If I'm commuting, I'm changing where I am. I'm changing my location. So if I add two numbers like a plus b, and if I want to switch them around, it's perfectly legal. I can do that if I add. I can do that if I multiply. AB equals BA. I can't do that if I subtract. I can't do that if I divide. Let me prove it to you real quick. If I have 5 minus 10, I can't say that that is equal to 10 minus 5 because that's negative 5 and that's positive 5. They are not equal. Same with division. I can't say 5 divided by 10 is the same as 10 divided by 5. Well, 5 divided by 10 is a half. 10 divided by 5 is 2, so they're not equal. That won't work. Just saying. Okay, associative. The word associative has the word associate kind of implied in it. It's a root word. So it's who I hang out with. So if I want A and B to be together and leave C out of the party, that's fine. I can also have A with B plus C. A is outside the party. And we can do the same thing with multiplication. AB, C equals A, B, C. Notice the pauses there. Okay, the identity property of addition. Identity is when you get what you had to start with. So if I'm getting exactly what I had when I started, then I haven't really done much to it. And if I want to have some number A, some variable A, which stands for a number, and I want it to equal A, and I want to actually do something to it, well then I could add 0, and I'd get what I had to start with. There's really no change to it. If I want to do that with multiplication, then I would multiply by, I'm glad you asked. I'd multiply by, not 0. Well, A times 0 is 0. A times what gives me A? Well, anything times 1 gives you what you had to start with. Anything. Can't think of an exception to that. The inverse property of addition, on the other hand, is not going to give me what I had to start with. It's actually going to give me what I call the identity. So this is going to be like A plus something is going to give me 0. Well, what would I add to get 0? Well, think about it this way. What would I subtract? If I had 5 and I wanted to get 0, I could subtract 5. Like I could say, oh, well, I have 5 minus 5. That gives me 0. Well, that makes sense. 5 minus 5 is equal to 0. I could say 5 plus negative 5 is equal to 0. So this is A plus negative A. And inverse property of multiplication, I could say A times something gives me, not 0, again, not 0, but gives me the identity, and it's going to be 1. So something times A gives me 1. Well, here it is, and this is a tricky thing. I'm going to use 5 again. I always use 5. 5 times something gives me 1, and it's not obvious because the number is going to get smaller. So it's not like 2. It's not 3. I mean, that'd be too big. It's a fraction, actually, and let's go ahead and just jump straight to it. 5 times a fifth is 1. Think about it this way. A fifth of 5 is 1. You can also think about it this way. If I had 5 times 1/5, I could put that over 1 and multiply across the top. Numerators, multiply across the denominators. 5 divided by 5 is 1. So, yeah. So, any number A times its reciprocal is equal to 1. There is an exception to that, and I'm going to write the exception down. A cannot be 0 because I can't divide by 0. It's just illegal. It throws the whole universe off kilter. Distributive property, you've seen it, you've done it, so we won't spend much time here, but it's A times some B plus C or whatever. You can probably put a variable in there if you want to. And what you do is you distribute the A, so A times B gives you AB. A times C gives you AC. AB plus AC. Okay, the addition property of equality, multiplication, subtraction, division, they're all very straightforward. So basically they say this. If I have A equals B, and I want to add the same thing to it, I could. So I can add the same thing. Whatever you do to one side, you do to the other side of the equal mark. This is perfectly okay. And I can do the same thing, like if A equals B, then I can multiply. So A times something is the same as B times something. And no surprises here, subtraction, same. So if two things are equal, I can subtract from both of them and get the same thing. And then division is exactly the same with one little caveat. I love the word caveat. It basically means one little exception. Caveat is a fantastic word. I can say A divided by C equals B divided by C, but there's an exception. It is illegal to divide by 0, so C cannot equal 0. All right, so we're going to solve some equations, and in the process of solving them, we are going to justify a lot of what we're doing. We may not justify every single step, but we will justify a lot of what we're doing. So we're going to go through these 5 examples, kind of algebraically and in terms of properties. So let's do it. 167 equals 6 plus 7 times 2. Those are what? Okay, hold on. That's not 13. That is not 13. Let's start with this. 7 times 2, 7 times 7x. So we still have 167, and that is 6 plus 14. 7 times 7 is 49x, and it's negative. And I'm not going to always write this on every single one of them, but I'm going to just kind of scribble over here on the side. Here's what I just did. I used the distributive property. I'm going to abbreviate it. So I just used the distributive property. And now I am going to simply just add basic addition. We need to clean up. Let's clarify that. I want to put some like terms together. This goes back to a different set of notes where we were simplifying expressions. So before we really even start this process, I need to simplify each side. So I need to simplify that. Well, that's pretty simple. I need to simplify that. That's not as simple. So let's clean it up. 6 plus 14 is 20. I still have negative 49x right there. And this side is 167. So I would write down what I did, but it's fairly obvious. I just added. So, I mean, it's not even really a property so much as it is just an operation I added. And so now what I'm going to do is subtract the same thing from both sides. I want to get x by itself. I want to know what x is. I want to know what x is. And I want you to show me. That was not funny. It was funny in my head, but anyway. What we're going to do is get rid of this 20. So I'm going to subtract 20 from both sides. And I'm going to actually put it here. So minus 20 and minus 20. I'm going to line it up vertically. And these cancel out. And when these cancel out, see, check this out. This is cool. I'm going to write down a couple steps at one time. 20 minus 20 is going to give me 0, which makes sense because of the inverse property of addition. I'm using the properties whether we realize it or not. So you know what, I will write that down. I'm going to put 0 minus 49x. And 167 minus 20 is 147, and that's equal to that. So I'm going to write a couple little steps here. I did a couple things. I actually used the subtraction property of equality because I subtracted the same thing from both sides. See? Subtract the same thing. And I also did 20 minus 20 and got 0, which is the inverse property of addition. I know it looked like subtraction because of the way I wrote it, but it's sort of that. So it's that, and it's also inverse of addition. We'll just put a plus sign. Okay, well, 0 means nothing when you're adding, so I can just take it away. I'm subtracting, but I'm really adding a negative 49. And if you want to get technical about it, we can really blow this thing out of proportion. We could turn these around because they're commutative. We can swap those if we wanted to and then say, oh, we're using the commutative property. But I'm not going to get that crazy with it. Technically, that's what I'm doing. But I'm not. I'm just going to say 147 equals negative 49x. And so that's what we have. And I used, in case you ever wanted to know, I used the, what did I use? I used the inverse property of addition. And technically I used the commutative property because I kind of turned it around in my head. And now we'll do one more little thing. Let's divide by negative 49. Obviously I'm using the division property. So one more little step here. I'm using the division property of equality. And let's see, 147 divided by negative 49 is negative 3. So negative 3 equals x. There we go. Negative 3 equals x. All right, let's clean up some of the other ones and do it a little bit more, simplify some stuff. Probably going to show a few less properties as we go, so let's speed it up a little bit. We have like terms here and here. We also have like terms, I want to switch colors though, because it's on the other side of the equal marks. We have like terms here and here. So 8x and 2x. Negative 8x plus 2x is going to give me negative 6x plus 16, or minus 16, equals. We're simplifying each side. Let's come to the other side. Negative 5x plus 7x is 2x. Okay, I want to get the x's together. I have some of them over here and some of them over here. We need to get them together. So here's what you could do, but it's not worth the trouble. You can subtract 2x and move it to this side, and that would give you 0 over here. Let's not. Let's add 6x. So I'm going to add 6x to this side. And whatever I do to one side, I better do it to the other. And that gives me a negative 16. This cancels out. It gives me a 0. I'm not going to write all that this time, but it gives me a 0. And that gives me 8x. And in case you really care what we did a few things. I'm not going to write every single thing, the work over here, but I will put that we did the inverse property of addition. That gave us the 0 that's understood. And we also did the addition property of equality. We added the same thing to both sides. And now we're going to divide by 8 to get x by itself. We have 8 times x. We'll divide by 8. And we end up with negative 2 equals x, and therefore we have used the division property of equality. Okay, next one. Whoa, gonna start by distributing. We need to simplify each side before we go any further. So 5 times 6 is 30, 5 times 3 is 15, plus 7 equals 127. Okay, this is one of those steps that we would use a property on, but it's sort of implied. Okay, this is where we can commute some stuff. I am actually going to show the step. It's not always necessary, but I'm going to show the step. I can swap these two, because I could be like 30 plus 7 is 37, and I'm right, it is. 15x plus 30 plus 7 equals 127. But I like to switch these so it looks like I'm actually able to put them together. It's a property. I'm using it. It's the it's the commutative property. I'm turning it around. I'm not going to write the steps on the side on this one. I'm going to go a little faster. So 15x plus 37 equals 127. We'll subtract 37 from both sides. That is the subtraction property of equality. Not writing all the steps this time. It gives us 90. We need to get x by itself. We have 15 times x. The opposite of times, opposite of multiplication, is division. So we'll divide by 15. And x equals 6. That's it. Okay. Let's distribute. Well, again, we're cleaning up each individual side. The left side is fine. It's just negative x. The right side is not fine. We need to distribute. So 7 times x, 7 times 2. Negative x equals negative x. That's odd. Plus 7 times x is 7x. 7 times 2 is 14. Okay, again, we need to simplify each side. In case you care about the properties, I don't have to write them. I just need to be able to justify. I have used the distributive property. Okay, negative x equals negative 1 plus 7 is 6 plus 14. Okay, so we basically just used basic addition right there. So let's get x together. We will subtract 6x from both sides. Cancel those out. That becomes 0. 6x minus 6x. Inverse property of addition. Just saying. Negative 1x minus 6x is negative 7x. That is equal to 14. And we need to divide. This is kind of obvious. If it was 7 times something gives me 14, well, the answer would be 2. But it's negative 7 times something gives me 14. So it's negative 2. That was the division property. Didn't really show it, but it's the division property. There we go. All right, one more. All right, we have this side of the equal marks. And it doesn't look clean, but it is. These are unlike terms. They don't go together. This, on the other hand, is a sloppy, sloppy mess. 7 times 5, or negative 7 times 5, negative 7 times negative 6. And that's all. Don't do negative 7 times negative 6n. That's not going to work, because this is not in parentheses. But we do have negative 35n. Negative 7 times negative 6 is 42. Minus 6n, and negative 5n plus 6. There we go. All right. Let's put some like terms together on this side. Let's simplify this side before we start moving some stuff around. So negative 35 minus 6 is negative 41n plus 42. This one may not turn out too clean. The other side stays exactly like it is. All right. So here's what we're going to do. You know what? This one's going to turn out it's going to turn out neat. Yeah, it's going to turn out okay. Just looking ahead. All right, we need to get our variables together and our numbers together. In case you care what we've done, we just basically put these two together. You could say that we used the commutative property and turned them around. Didn't do that though. So let's add 41n to both sides. We'll line it up with the like terms. Those cancel, it becomes 0. And if I'm going to move the n's to the left, then I need to move the number to the right. So we'll subtract 6. Those cancel out. So negative 5 plus 41 is 36n. 42 minus 6 is 36. How convenient. 36 times something gives me 36. Well, we'll divide. Actually, I'll go ahead and tell you, this is almost like a property itself. 36 times what gives me itself? Anything times 1 gives me itself. The answer is 1. So we'll divide by 36. And n is equal to 36 divided by 36, which is 1. That was the division property of equality.